bushfire continues to rage in the Australian outback, destroying acres of natural forest and the habitat of millions of animals. The areas was affected are the southeast, although help is at hand from the recent research undertaken by the International Boreal Forest Research Association. This association, based in Sweden, has held meetings throughout the world discussing the global issues of forest fires. Natasha Kaplinski corresponds from Australia.
Fire started?
Well, forest fires are often caused by human events, although they are naturally occurring. They're often caused by freak weather conditions such as lightning, but more often than not caused by the hot temperatures drying out vegetation, which can cause spontaneous fires. We call that kind of temperature the flash point.
So Dr. Helgren, if this fire has been caused by climatic conditions, surely this has been occurring for millennia and the plants will have evolved some kind of adaptation against this happening.
Plants can't just walk away from fires like we can. They need certain adaptations to protect themselves and quickly extinguish fires. Trees in fire-prone environments often have thick bark. In the case of the American redwood, this bark acts as a heat shield to protect the rest of the tree, whereas in the eucalyptus plants, the bark fragments and falls so that when it catches fire, it can extinguish the fire quickly and protect the rest of the tree. These fire-tolerant plants can withstand some fires and then can re-sprout.
So, Dr. Helgren, this feature of plants having adaptations towards setting on fire is known as the Much hypothesis. Is the Much hypothesis now widely accepted?
Well, no, on the contrary. Since its conception in the early 1970s, fire ecologists have questioned its merit and have put some of the characteristics down to coincidence. Personally, I stand by the Much hypothesis, and there is a huge amount of evidence in its favour.
Are there any other problems that the passage of fire can cause for the plants?
The fire produces a nutrient-rich ash, which makes the soil very fertile. But because of the heat, it breaks down the complex molecules, so there's a danger of leaching. The consequence of combustion is that the acidic organic molecules are used up as fuel. This may increase the pH of soil, which can result in some plants not being able to grow.
So Dr. Helgren, in what way can it be said that the fire is a necessary part of the life cycle of some plants in Australia?
There is a process called serotony. The heat of the fire stimulates the melting of waxy resins, which we use to encase the seeds. The waxy layer is known to protect and keep the cones closed in pines. After the fire passes, the protective coats melt. The seeds are released into the environment in huge quantities. The advantage of this is that the seeds have highly fertile soil to land on, and they have no competition or shading from older or more established plants.
It has been noticed that after forest fires, plants bloom in large quantities. Have you any idea why this occurrence takes place?
Well, fire has been shown to stimulate the release of chemicals that can trigger flowering. Some plant hormones, such as ethene, they're highly volatile and can be released with the smoke of fires. When they come into contact with buds, they can trigger the reaction, which results in the opening of flowering organs. This is why we see after fires, sometimes the landscape suddenly comes into bloom.
So despite the widespread damage that has been caused by the fires, there are some positive repercussions. Well, thank you very much, Dr. Helgren. This has been Natasha Kapinski and Dr. Jan-Erik Helgren reporting for BBC News. Back to the studio.
Thank you, Natasha. Now Michael Fish for the weather.